Hello guys, we are back with another interview problem, that is two-sum problem. So in this problem, we have given an array of integers and a number k, okay? And we have to write a program to find indexes of two elements in an array for which the sum is equal to k, okay? So let's take few examples. So let's say this is the array, right? And the sum given is 13. So we have to find indexes of two elements for which the sum is k. Okay, so here we have to first find two elements for which the sum is 13. So we can see that 4 and plus 9 is 13. So found indexes are 4 and 1. So there's 0, 1, 2, 3, 4, 5. So 1 and 4. Okay, so in another example, we have 1, 2, 3, 4, 5, and sum is 9. So indexes are 4 and 3, these two. And in this example, there are no indexes for which the sum is 10. So we'll print no indexes found. So let's see how we are going to solve this. So let's first discuss the brute force solution. So in that solution, we'll use the nested loops. Basically, we'll add every element to rest of the other elements in the array and check if the sum is equal to 13, and if yes, return those indexes. So for example, we'll add 5 with 4, so that is 9, then 5 with 7, so that is 12, 5 with 3, that is 8, and so on, right? So once that is done, then we'll start adding 4 with the rest of the elements, and then 7 with the rest of the elements, and so on, right? So we'll take nested loops, so the time complexity would be O of n square, right? So now we are going to reduce the time complexity. So can we sort this, right? The answer would be no, because the sorting would change the order of the elements, right? And the order here is important because we need to find the indexes for which the sum is 13, right? So we cannot sort it. So the better solution would be to use map or dictionary, right? So what we'll do, we'll maintain a map where the key would be the element itself, right? Element, and the value would be its index. Okay, so first we'll iterate. So we'll take 5. So we'll enter 5 and the index 0, right? Sum required is 13. So now what we'll do, 13 minus 5, that is, now we require 8, right? So 8 is not present in the map. So we'll move to the next element. So that is 4. So we'll enter 4 and index 1, right? And we'll also check 13 minus 4, which is 9. So we'll check if the 9 is present in the map. It is not present. So we'll go to the next element. So that is 7, right? So 13 minus 7 is 6. So 6 is also not present in the map. So we'll enter this 7 and the index 0, 1, 2, 3, 4, 5. So we'll enter 2. Now the next element is 3. So 13 minus 3 is 10, right? So check if 10 is present in the map. It's not present. So we'll enter 3. So that is 3 and the index is 3. Now the next element is 9, right? So 13 minus 9 is equal to 4, and 4 is present in the map, right? So we have found two elements. One is 9 and one is 4, for which the sum is equal to 13. So we know the index for 9 because we are iterating. So this index is 4, and the 4 is present in the map. Okay, so we'll get the index of 4, which is 1. So our answer would be 4 and 1, right? These are the indexes. So basically here, what we are doing is, let's say there are two elements, A plus B, A and B, for which the sum is 13, right? So A is equal to 13 minus B, right? So now if we apply this to the operations which we are doing here, the B is the current element, right? B is the current element which we are iterating, right? And we are looking for A. So what is A? 13 minus B, right? So if the current element is 9, which is B, so 13 minus 9, which is 4. So A plus B would be equal to 13, right? So what would be the time complexity here? It would be O of n, because we are doing only one iteration, right? So that is the time complexity. So that is definitely better than O of n square. And the space complexity would be O of n, because we are maintaining a map, right? So let's go back to the problem, and yeah, let's read out the approach. The brute force use nested loop, all possible pairs in the array, check if the pair sum is equal to k. If found, then print the indexes, right? The time complexity is O of n square. The better solution, to use map. So construct a map that stores array element as key and index as value. Iterate the array for every element x, right? Calculate y is equal to k minus x. Now we need to look for y in the map. So check if y is present in the map. If yes, we have found the pair for which the sum is equal to k. Get the index of y from the map, print it along with the index of x, right? If not, add x and its index to the map. So time complexity is O of n, space complexity is O of n. So let's look at the code. So this is our function, right? It takes parameter as array, integer array, and the sum, right? So this is our map, and initially x and y is equal to -1. Okay, and now what we are doing here is we are iterating the array. So this is num1, that is the current element, and the num2, which is b is equal to k minus a. So b is num2. So num1 plus num2 would be is equal to sum, right? So now we'll check if map contains num2. If yes, we have found the pair, right? So x is equal to I, right? The first index, and y is equal to map dot get the num2. Get the index from num2 from the map. So x and y, right? And break. We have found the pair. Okay. Else put the num1 and its index in the map. Okay. Once you are here, uh, check if x is not equal to -1 and y is not equal to -1, which are these values, right? So if it is not, that means x and y has some assigned value. That means we have found a pair. So we'll print it. Else, no indexes are found. Okay, so let's quickly run this code. So that's the same example, and yeah. So sum 13, 9, and 4. So index 4 and 1. Okay, and let's say if we have to find the sum which doesn't exist, let's say 33. So it says no indexes are found. Okay, so this is how we are going to solve this problem. Now we can mark this problem as completed. And yeah, please visit our website tutorialhorizon.com for more interview problems. We'll see you guys in the next video. Bye bye.